Let's move to the question number 15. The distance of the point P from the line QR through Q with the coordinates -3, 6, 2, which makes equal angles with the axis is first option 3, second option 8, third option √2, and fourth option 2√2. P is a point given to be with the coordinates -2, 3, 1, and you have a line passing through -3, 6, 2, and which is supposed to be making equal angles with the coordinate axis, which would mean that the DRs of that line can be taken as 1, 1, 1 DRs. Now you are asked to find out the distance from point P to this line. R is some point somewhere on this line, QR. Okay. Distance would always mean the shortest distance from the point to this line, and that is the perpendicular distance. Okay, let's write the equation of this line. We know one point and the DRs, so x minus of -3 by the 1, and then y minus 6 by 1, and z minus 2 by 1. Any point on it can be given by the parametric form. What is it? T minus 3 comma general point. So let's call this foot of the perpendicular to be T minus 3 comma T plus 6, 1 into T plus 6, T plus 2. So this foot, let's call it as some M. M can be given by the coordinates T minus 3, T plus 6, and T plus 2. Now I need to find out this point T so that I can find out the distance PM. So how do we do that? It's perpendicular to the QR line. Make use of that. PM is perpendicular to QR. What are the DRs of PM? T minus 3 minus of 2 minus 2. So minus of -2 comma T plus 6 minus 3 comma T plus 2 minus 1. These are the DRs of PM line. So what is that? T minus 1 comma T plus 3 comma T plus 1. Now the dot product of this DRs with 1, 1, 1 has to be 0 because PM is perpendicular to QR. So T minus 1 into 1 plus T plus 3 into 1, so that is same, T plus 1 has to be 0. Now this 1 and 1 cancels and you have 3T plus 3 is equal to 0, so that gives us T equal to -1. So T has to be -1, so we get the coordinates of the M to be, for the coordinates of M, we can take M coordinates to be T minus 3, so -1 minus 3, so -4, T plus 6 minus 1 plus 6, 5, T plus 2 minus 1 plus 2, 1, -4 comma 5 comma 1. So I just need to find out PM length now. Length of PM is -2 minus of -4 whole square, or 3 minus 5 the whole square, 1 minus 1 the whole square under root. So that makes it 2 square plus 2 square under root, and that gives us √2. So the length is 2√2. So option 4 is correct. Answer is 4. Fourth option is correct. Let's move to the next question. Question number 16. A plane which passes through the point 3, 2, 0 and the line x minus 4 by 1 is equal to y minus 7 by 5 is equal to z minus 4 by 4 is first option x minus y plus z is equal to 1. Second option x plus y plus z is equal to 5. Third option x minus 2y minus z is equal to 1. and fourth option 2x minus y plus z is equal to 5. The plane is passing through the point 3, 2, 0. So 3, 2, 0 is one of the points. And we also have a line lying on the plane. The line is given by the equation x minus 4 by 1 is equal to y minus 7 by 5 is equal to z minus 4 by 4. Now, let the equation of the plane be a into x minus 3 plus b into y minus 2 plus c into z minus 0 equal to 0. So, a plane passing through the point x1, y1, z1 and whose drs of the normal are ABC, drs of the normal are ABC is given by a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Here the point that is given is 3, 2, 0. So, instead of x1, y1, z1 we can use that point. And moreover, you see that this line is lying on this plane. So, this point 4, 7, 4 is clearly a point on the plane. So, 4, 7, 4 should satisfy the equation of this plane. So, instead of x, y, z I can substitute that point. So, 4, 7, 4 lies on the plane, which implies a into 4 minus 3, that is a into 4 minus 3 plus b into 7 minus 2 plus c into 4 minus 0 is 0. That gives me a plus 5b plus 4c is equal to 0. That's one equation in ABC. One more equation in ABC we can frame is the drs of this line are 1, 5, 4. So, the plane is like this and the line is like this, line is on the plane. So, drs of the normal are like this, normal is like this, so the normal has to be perpendicular to this line, which means that a into 1, plus b into 5 plus c into 4 is 0. Now, as you observe that we are getting the same equation, it appears that this line is actually passing through 3, 2, 0. So, we are not getting two independent equations. Second equation is also same as the first one. So, now we have to go by options. Now, first option says x minus y plus z equal to 1. So, you could take a to be 1, b to be minus 1 and c to be 1. A is 1, b is minus 1 and c is 1 from here. Let's see if it satisfies that equation. What is it I get? A into 1 plus 5 into minus 1. A is 1, so 1 plus 5 into minus 1 plus 4 into 1 is 0. So, it appears that the first equation will be the one, x minus y plus z equal to 1. Let's see if it satisfies this equation. At this point, 4 minus 7 plus 4 is equal to 1. That's okay. And then we have here 3 minus 2 plus 0 is equal to 1. So, both these points are satisfied by this equation. And also, the equation governed by the drs is also satisfied by this equation, x minus y plus z is equal to 1. So, the right option here is answer 1. Option is 1. Let's move to the next question, question number 17. The equation of the plane through the midpoint of the join of A 4, 5, minus 10 and B minus 1, 2, 1 and perpendicular to AB is, first option r bar dot 5i plus 3j minus 11k plus 135 by 2 is equal to 0. Second option r bar dot 5i plus 3j minus 11k is equal to 135 by 2. Third option r bar dot 3 by 2i plus 7 by 2j plus minus 9 by 2k is equal to 5i plus 3j minus 11k. And fourth option r bar dot 5i plus 3j minus 11k plus 185 by 2 is equal to 0. Here we are interested in finding the plane which will go midway between this segment AB. A is 4, 5, minus 10 and B is with the coordinates minus 1, 2, 1. And that plane has to be perpendicular to AB. So it has to be the midpoint of AB, say M, lies on the plane, and also it has to be perpendicular to it. So because the options are all given in the vector form, let's write the equation in the vector form. What is the vector form of the equation of the plane? R bar minus A bar dot N bar is equal to 0, where A bar is the position vector of one of the points on the plane and N bar is a vector normal to the plane. Now what is a vector normal to the plane? Very clearly here AB vector is N bar. AB vector is N bar. So AB vector I can write it in the form of 5i plus 3j minus 11k. AB vector or BA vector, that hardly matters. Okay, so AB or BA, you can take it as N bar. R bar minus A bar, what is the midpoint? The midpoint is one of the points on the midpoint of the segment is a point on the plane. So what is that? 4 minus 1 by 2, this M we can take it as 4 minus 1 by 2, 5 minus 2 by 5 plus 2 by 2, comma minus 10 plus 1 by 2. So that makes it 3 by 2 comma 7 by 2 comma minus 9 by 2. So our A bar we can take it in the form of A bar is, this is our N bar, and A bar we can take it in the form of 3 by 2i plus 7 by 2j minus 9 by 2k. That is the position vector of that point, we can write like this. Now let's put them in this equation. So what is it? We get R bar dot N bar must be equal to A bar dot N bar. I rewrite this equation. So what is that? R bar dot N bar is your 5i plus 3j plus 3j minus 11k. So 5i plus 3j minus 11k. What about A bar dot N bar? So just have to take the dot product of this. 5 into 3 by 2, that is 15 by 2, 3 into 7 by 2, that makes it 21 by 2, 11 into 9 by 2, 99 by 2. So the total is 135 by 2. So clearly the right option is option 2. So option 2 is the right answer. Let's move to the question number 18. If the equation of the plane perpendicular to the z-axis and passing through the point 2, minus 3, 4 is ax plus by plus cz is equal to d, then a plus c by d is equal to first option 4, second option 3 by 4, third option 3 and fourth option 1 by 4. Now we have a plane perpendicular to the z-axis. Now let us think that this is x-axis, this is y-axis and this is z-axis. A plane perpendicular to z-axis. So the normal DRs will be the DRs of the z-axis. What are the DRs of z-axis? 0, 0, 1. So these are the DRs of the normal to the plane. So a plane perpendicular to z-axis has to be parallel to xy plane and hence it is taken as z equal to some constant. But then we are given that 2, minus 3, 4 is a point on it. So the z coordinate of any point on this plane has to be constantly 4 then. So z equal to 4. So the plane is z equal to 4. So we can rewrite the plane as 0x plus 0y plus 1z is equal to 4. So comparing with what is given, ax plus by plus cz is equal to d. So a happens to be 0, b happens to be 0, c happens to be 1 and d happens to be 4. So clearly A plus B plus C by D is equal to 1 by 4. The right option is 4, fourth option. Let's move to the question number 19. The equation of the plane lying in midway between the two parallel planes, 2x minus 3y plus 6z minus 7 is equal to 0 and 2x minus 3y plus 6z plus 7 is equal to 0 is first option 2x minus 3y plus 6z plus 1 equal to 0. Second option 2x minus 3y plus 6z minus 1 is equal to 0. Third option 2x minus 3y plus 6z is equal to 0. Fourth option 2x minus 3y plus 6z is equal to 11. Let's move on here. When you have two parallel planes, we can write the equation of the planes to differ only by a constant. So this plane we can take it in the form of ax plus by plus cz plus d1 d2 equal to 0. Now a plane in the midway between them, that is exactly in the middle, midway between them, parallel to both, we can give it in the form of ax plus by plus cz plus, no, they differ only by a constant. That constant is given by d1 plus d2 by 2, that is average of these two constants, average of d1 and d2. It's clear that the distance between this and distance between this two planes will be the same. This length and this length will be same, because we know that the distance between two parallel planes is, when you write the equations in such a way that they differ only by a constant, is modulus of the difference of the constants divided by square root of a square plus b square plus c square. So here this distance and this distance would be same by taking d1 plus d2. So now we can clearly use this 2x minus 3y plus 6z plus 7 equal to 0 is one of the equations. 2x minus 3y plus 6z minus 7 equal to 0 is the plane P1. Let's call this P1, this P2. Now the plane P3 is given by, we just have to take the average of these two. 2x minus 3y plus 6z, what is the average? Is clearly 0 is equal to 0, plus 0 is equal to 0. So this is the equation of the required plane, and that is clearly seen in the option 3. So answer is third option. Let's move to the question number 20. The area of the triangle formed by the plane 2x plus 3y plus 6z plus 9 equal to 0 with y-axis and z-axis is in square units. First option 9, second option 9 by 2, third option 9 by 4, fourth option 9 by 8. Let's see how it goes. We have the plane. Let's take this as x-axis, this as y-axis, and this is z-axis. A plane in its first octant, it appears this way. So we have a plane. Now this is, let us say this is the origin here, OAB. We have to find out the area of the triangle OAB. Now what is the equation of this plane? The equation of this plane, what is the equation of this plane? 2x plus 3y plus 6z plus 9 equal to 0. Putting here, I put x equal to 0 and z equal to 0 here, because on the y-axis x and z coordinates are both zeros. So if I put x equal to 0 and z equal to 0, then what do I get? 3y plus 9 is equal to 0. So that makes it minus 3. So this length as such will be 3 units. 3 units. What about this? On the z axis, the x coordinate and y coordinate have to be 0. So 0, comma 0, and z coordinate 6z plus 9 is equal to 0. So z will be equal to minus 9 by 6 or minus 3 by 2. This is minus 3 by 2. We know that the area of the triangle OAB, area of the triangle OAB is half into mod of OA into mod of OB, the distance. What is OA? 3 units, absolute. Half of 3 into, what about OB? That is modulus of minus 3 by 2, that is 3 by 2. So that makes it 9 by 4. So clearly the area of the triangle OAB, that is required area, is 9 by 4, and that is available in the option 3. So option 3 is the right answer. Let's move to the question number 21. Equation of a plane bisecting the angle between the planes 2x minus y plus 2z plus 3 equal to 0 and 3x minus 2y plus 6z plus 8 equal to 0 is, first option 5x minus y minus 4z minus 45 equal to 0, second option 5x minus y minus 4z minus 3 equal to 0, third option 23x plus 13y plus 32z minus 45 equal to 0, fourth option 23x minus 13y plus 32z plus 5 is equal to 0. So let's see, we are interested in the plane bisecting the two planes. So we have, let's say we have two planes like this meeting. We want a plane which is bisecting these two planes. Now we know that the equation of the bisecting plane is given by is equal to plus or minus a2x plus b2y plus c2z plus d2 by root over a2 square plus b2 square plus c2 square. I mean a1x plus b1y plus c1z plus d1 equal to 0 is the first plane. So here we have 2x minus y plus 2z plus 3 equal to 0. A second plane we are given as 3x minus 2y plus 6z plus 8 equal to 0. We got to find out the plane bisecting the angle between them. So there are two bisecting planes, as you can see. The one which will be perpendicular to this also, again bisecting the acute angle, bisecting the obtuse angle. Since we are only given one of the planes, it may be from the options we have to check which one is the right option. So first let's write the formula. Apply a1 b1 c1 are 2 minus 1 2 there. So 2x minus y plus 2z plus 3 by root over 2 square plus minus 1 square plus 2 square makes it 4 plus 4 plus 1 3 under root of 9, that is 3, a2x plus or minus a2x, that is 3x minus 2y plus 6z plus 8 divided by 3 square plus minus 2 square plus 6 square under root. So we get 2x minus y plus 2z plus 3 by 3, because 4 plus 4 plus 1 under root, that is 3, that's equal to plus or minus 3x minus 2y plus 6z plus 8 divided by 9 plus 4, 13 plus 36, so 49, the root of it 7. So cross multiply, what do you get, and put a plus sign and a minus sign, and you will see that one of the options. So what do we get? 14x minus 7y plus 14z, cross multiplying, plus 21 is equal to plus or minus 9x minus 6y plus 18z plus 24. So maybe transposing that side, taking a plus sign, we get one bisector. What is the bisector? 5x or minus y minus 7y. When you take it the other side, you get a plus 6y, so minus y. 14z minus 18z, so minus 4z. 21 minus 24, that is minus 3 equal to 0. So that's clearly seen in the option 2. Let's write the other one also, taking the minus sign. So what do we get? 23x minus of minus will make it plus, but when I take it the other side you get a minus. So minus 13y, 14z, 32z, 21 plus 45 is equal to 0. So plus 45 equal to 0. So if it had been minus 45, even the third option would have been correct. But so of the two planes, this is the one that is given in the option. So we can opt for answer as 2. Let's move on to the next question. Question number 22. The length of the perpendicular from origin to the plane passing through three non-collinear points whose position vectors are a bar, b bar, c bar is, first option, modulus of 2 into box of ABC divided by a cross b plus b cross c plus c cross a. Second option, box of ABC. Third option, modulus of box of ABC divided by modulus of a cross b plus b cross c plus c cross a. And fourth option is box of ABC vectors square. We are asked to find out the length of the perpendicular from origin to the plane containing 3 points which are non-collinear points. Through 3 non-collinear points, we know that we have a unique plane passing through them. We can frame a unique plane. Now since this point origin is not on the plane, had it been on the plane, one of the options would have been 0. So it appears that clearly the point is not on the plane. So we got to find out this distance, perpendicular distance. From O we can join up A, we can join up B, and we can join up C. We get a tetrahedron with OABC. We get the tetrahedron OABC. Now the altitude of this tetrahedron is what you want. Okay, so H, let's call it as M. M is the foot of the perpendicular from origin to the plane containing ABC. Now we know that volume of this tetrahedron is 1/6 of box of ABC. Volume of the tetrahedron is 1/6 of box of ABC. Of tetrahedron OABC. The modulus is required. Okay, but that is also given by 1/3 of area of the base. What is the area of the base? We know that area of the base containing this with the vertices ABC is half of mod of A cross B plus B cross C plus C cross A. That is, area of the base is mod of A cross B plus B cross C plus C cross A. This is half mod AB cross AC into the height H. So this clearly 1/6 of box of ABC and a modulus is equal to 1/6. This 1/6 and this 1/6 can be cancelled, and clearly H is equal to box of ABC modulus of it divided by modulus of A cross B plus B cross C plus C cross A. B cross C plus C cross A. It's more or less a formula that you can remember. That is the distance from origin to the plane containing the 3 points A bar, B bar, C bar is box of ABC by A cross B plus B cross C plus C cross A, modulus of that. So H is this. Clearly that is seen in the option 3. So answer is option 3. Let's move to the next question, question number 23. A variable plane intersects the coordinate axis at ABC, capital A, capital B, capital C, and is at a distance of small p from origin. Then the locus of the centroid of the tetrahedron OABC is, first option, 1 by x square plus 1 by y square plus 1 by z square is equal to 1 by p square. And second option, 1 by x square plus 1 by y square plus 1 by z square is equal to 4 by p square. Third option, 1 by x square plus 1 by y square plus 1 by z square is equal to 16 by p square. And fourth option, 1 by x square plus 1 by y square plus 1 by z square is equal to 16 p square. So we have a variable plane, the variable plane, let's say, whose distance from, so this plane is moving like this, maintaining the constant distance p from origin. Now let us say the variable plane meets x-axis at a0, 0, y-axis at 0, b, 0, and z-axis at 0, 0, c. So the equation of this plane in the intercept form can be written as x by a plus y by b plus z by c is equal to 1. Equation of the plane ABC. Okay, now we know that the perpendicular distance from origin to this plane is 1 by a square plus modulus of minus 1 by a square plus 1 by b square plus 1 by c square under root, and that is given to be p. So what we have here, we can write this as 1 by a square plus 1 by b square plus 1 by c square is equal to 1 by p square. But we know that the centroid of this tetrahedron OABC, now you have a tetrahedron OABC. This is O, let us say this is A, this is B and C. We have a tetrahedron OABC, and then the centroid of it is given by x1 plus x2 plus x3 plus x4 by 4. So 0 plus centroid G will be given by a by 4 comma b by 4 comma c by 4. Because 0 plus 0 plus 0 plus a by 4. Similarly, the y coordinates, z coordinate. Okay, so this is it. Now we have to write an equation satisfied by this. We have to write the locus of G. We have an equation in ABC here. So let's call this as some x, y, z. So what is A? 4x. So we get 1 by 4x whole square plus 1 by 4y whole square. Similarly, B is equal to 4y, 1 by 4z the whole square is equal to 1 by p square. So clearly from here we get 1 by x square plus 1 by y square plus 1 by z square to be equal to 16 by p square, and that is the answer that's available in the option 3. So answer is the option 3. So let's move on to the question number 24. A variable plane passes through the fixed point a comma b comma c and intersects the coordinate axis at capital A, capital B, capital C. The locus of the point of intersection of the three planes through capital A, capital B and capital C and parallel to the coordinate planes is, first option, x by a plus y by b plus z by c is equal to 1. Second option, x by bc plus y by ca plus z by ab is equal to 1. Third option, ax plus by plus cz is equal to 1. Fourth option, a by x plus by plus c by z is equal to 1. Here we have a variable plane, but it's always passing through a fixed point. So this plane is moving in the space but hinged to a one point, say a comma b comma c. This is fixed point on the plane. Is fixed. Let us say this plane is meeting the x-axis at some point alpha comma 0 comma 0, and this point is some 0 comma beta comma 0, y-axis at and z-axis at 0 comma 0 comma gamma. Therefore, the equation of this plane in the intercept form, we can write it in the form of x by alpha plus y by beta plus z by gamma is equal to 1. Intercept form of the equation of the plane ABC. ABC plane. And what else we know? We know that the point A comma B comma C lies on it. So instead of x, y, z, I can substitute A, B, C. So A by alpha plus B by beta plus C by gamma is equal to 1. Gamma is equal to 1. But we are interested in the locus of the point of intersection of the planes through A. So I fit a plane through A. What will that plane be? X equal to alpha. Fit a plane through B, that's going to be y equal to beta. And the plane through C, z equal to gamma. So another plane we can fit like this. Where do these three planes intersect? They intersect at this point. And what will be the coordinates of this point? Alpha comma beta comma gamma. So we want the locus of this point, P. So locus of P is, instead of alpha beta gamma, we have to replace it with the general coordinates x, y, z. So let's do that. What do we get? A by x plus b by y plus c by z is equal to 1. So I am using this equation and to write the locus of the point alpha comma beta comma gamma, which is actually the intersection of the planes through A, capital B and capital C. That will be the point alpha comma beta comma gamma. So replacing that with the general coordinates, we have this, and that's clearly seen in the option 4. Option 4. Question number 25. If P is equal to 0, 1, 0 and Q is equal to 0, 0, 1, then the projection of PQ segment on the plane x plus y plus z equal to 3 is first option 2, second option root 2, third option 3 and fourth option root 3. We are given 2 points PQ which are not on the plane, and we are asked to find out the projection of that on the plane x plus y plus z is equal to 3. So what you have to do is we have to drop a perpendicular from P onto this plane, Q onto this plane. Let's call it as Q dash, P dash. This length P dash Q dash is the projection of PQ onto the plane. So this is the scheme. So what you need to do is we have to find out the projection of this point P, the foot of the perpendicular from the point P onto the plane. What is this point P given by? 0, 1, 0, and this point Q is given by 0, 0, 1. So now then let's find out the coordinates of the foot of the perpendicular from x1 comma y1 comma z1, concept place, onto the plane ax plus by plus cz plus d equal to 0 is, foot is given by, let's say this is P and this is M. Coordinates of M, let us call that as some alpha comma beta comma gamma. Alpha minus x1 by A is equal to beta minus y1 by B is equal to gamma minus z1 by C is equal to minus of, I need to substitute this point here, ax1 plus by1 plus cz1 plus d by a square plus b square plus c square. So equating this alpha minus x1 with this, I will get the value of alpha. Similarly beta, gamma, we can find out the foot of the perpendicular from P onto the plane. This is the concept. So instead of this point x1, y1, z1, you have 0, 1, 0 on one occasion, 0, 0, 1 on the other occasion. Instead of xy alpha ABC, we have 1, 1, 1 and d is minus 3. So substituting here, we get the points P dash and Q dash, and then we need to find out the distance between P dash and Q dash. P dash we'll find out here. What is that? Alpha minus 0 by 1 is equal to beta minus 1 by 1 is equal to gamma minus 0 by 1 is equal to, I'll rewrite this in the standard form, and now I just have to substitute this point 0, 1, 0 here. So 0 plus 1 plus 0 minus 3 by 1 square plus 1 square plus 1 square. So alpha will be, in this case, alpha by 1 is equal to, what is this? We can simplify this. 1 minus 3 minus 2, minus of minus 2, 2, 2 by 3. So alpha by 1 is equal to 2 by 3. Beta minus 1 by 1 is equal to 2 by 3. Gamma by 1 is equal to 2 by 3. So that gives me alpha to be 2 by 3, beta to be 2 by 3 plus 1, 5 by 3, gamma to be again 2 by 3. So P dash coordinates are 2 by 3 comma 5 by 3 comma 2 by 3. Similarly, the Q dash coordinates also we can find out. Just in place of alpha, this point here 0 1 0, we have to take 0 0 1. So we'll do that. So we'll write Q dash here, alpha minus 0 by 1, beta minus 0 by 1, gamma minus 1 by 1 is equal to this. And we need to substitute this point 0 0 1. I think the same will be there, 2 by 3. Okay, 0 plus 1 minus 3. So the answer will be the same. Now the coordinates will simply slightly get changed. We get beta to be 2 by 3 and gamma to be 5 by 3. So this point is 2 by 3 comma 2 by 3 comma 5 by 3. So what do we get? The distance is clearly 2 by 3 minus 5 by 3 whole square. So that's 1 square plus 1 square under root, that is root 2. Clearly P dash Q dash is root 2. We can just use the distance formula and that is clearly root 2. Therefore, the right option is, answer is in 2. Let's move on to the next question, question number 26. The equation of the plane passing through the origin and containing the lines whose DCs are proportional to 1 comma minus 2 comma 2 and 2 comma 3 comma minus 1 is, first option x minus 2y plus 2z is equal to 0, second option 2x plus 3y minus z is equal to 0, and third option x plus 5y minus 3z is equal to 0, and fourth option 4x minus 5y minus 7z is equal to 0. Now we are interested in finding the equation of a plane which contains two lines whose DCs are proportional to 1 minus 2, 2, and we have 2 comma 3 comma minus 1, and moreover we are also given that we got to find out the equation of the plane passing through the origin. Also origin is a point on the plane. So DRs of these lines are, so DRs of the normal, let's take them as ABC. So the equation of the plane, we can write it as ax plus by plus a into x minus 0 plus b into y minus 0 plus c into z minus 0 is equal to 0. Equation of the plane passing through x1, y1, z1 is a into x minus x1 plus b into y minus y1 plus c into z minus z1. So instead of x1, y1, z1 you have 0, 0, 0. That's one thing. Moreover, this ABC are the DRs of the normal. So that has to be perpendicular to this line as well as this line. So what do we do? A minus 2b, the dot product has to be 0, is equal to 0, and 2a plus 3b minus c is also 0. Now we know that ABC can't be simultaneously 0. So we have a system of 3 equations in 3 unknowns ABC, homogeneous system. ABC can't be all zeros. So what is it? The determinant of the coefficient matrix has to be 0. So the equation of the plane taken in the form of 1 minus 2, 2 and then 2, 3 minus 1. Open up this determinant, x into minus 2 into minus 1, that is 2, 2 minus 6, that is minus 4, minus y into what? 1 into minus 1, minus 1, minus 4, plus z into 3 minus of minus 4, that is 7, that is equal to 0. That makes it minus 4x plus 5y plus 7z is equal to 0, and that is clearly seen. I can rewrite this equation as 4x minus 5y minus 7z is equal to 0. Multiplying by minus sign, we have it, and that's clearly seen in the option 4. So answer is option 4.